Hello everyone. In this video, I want to talk to you about the factors influencing sensor design, network design. Now, I'll talk to you about different sensors, functionality, different applications. Now, I'll talk to you about the sensor being ad hoc and everything. But in this video, I'd like to talk to you about how those network design are performed. Okay. So basically, these are the sensors, okay? These are the number of sensors. For example, the sink is basically the collector of all the information, and sink has a capability of communicating to the user or cloud through internet, satellites, LTE, 5G, whatever, and the sink has the functionality. So all of these sensors somehow need to be able to send it to the sink. So for example, I talked to you about the ad hoc. So A needs to send it to B, then they piggyback on the B's information, send it to C, then piggyback on that. And then they send it to E, and they eventually gets to the sink. So A's information get to the sink, but you piggyback on it. You cannot, depends on your sensor network design. You can perform more of an ad hoc functionality. You collect the information, you can send to the sink. Okay, so and those are the sensor fields. There's a sensor node. This is typically one of the cases. Sometimes the sink here, instead of have ad hoc cases, you can have centralize all the sensors individually connect to the sink. This is more of the centralized version of it. But problem with that is scalability issue. Another thing is if a sensor is farther away, it takes good amount of power to communicate with one another. So it depends how you want to design it. Design depends on what application you're trying to be used in this. Okay. So this is the very high level of network design. So when you consider the network design, you have to think about the fault tolerance, scalability, hardware constraint, sensor network technology, topology, environment, transmission media, and the power consumption. All of those are the important items to consider. So for example, fault tolerance, how can you provide all the functions and capability, have a continual connection without being interrupted, right? If one node is fair, then other node can pick up the slack and be able to continue to transmit the data. So that's a fault tolerance. You don't expect it to have 100%, without any failure. There are recent cases that it's not able to send the data to the destination. Okay, the scalability is how many nodes do you want to connect to the sink is one of the case, and if the more sensor are there, also depends on the density. It can be a very complex to send the data from one point to another. There could be a lot of data, right? So are they able to process all the data, especially when it's connected to the sink, right? So production cost, what's the cost of making the single sensor? What are the capability and functionality does it involve? More functionality, more capability, the cost becomes very expensive, right? For example, when it needs to have a wireless interface, then it becomes more expensive compared to just a wire connected device. So you have to go back to the requirement, what he's trying to do. So you have to consider all of that and determine the actual cost. So also the hardware constraint, how much RAM does it have? What's the, what do you call that, storage amount, okay? And, what's the, how sensitive the sensors, say, is it pretty sensitive versus not sensitive? So what are the power unit, power generation? Those are the being very important, okay? So, number of things you have to, consider, okay? So also the sensor network topology, how you want to deploy those. For example, pre-deployment is you just figure out, how you're going to deploy it, okay? And how you're going to deploy. Are you going to drop in that, maybe a 10,000 level, 10,000, miles high, whatever the feet high, then you're going to drop it and let it spread. Those are the things that you have to consider. How you're going to pre-deploy it, and what are the deployment phase, and also the post-deployment phase. Once you lay it down, so what would be the process? Is it going to be dissolved into the environment, or do you have to somewhat pick it up, right? So what would be the post-deployment phase? Do you have to do redeployment? Do you have to, send it out again? And that's another case, okay? So, when you talk about the, environment, there are a lot of cases, as you can see here. Is it located at the busy intersections? That there are more challenges involved? A lot of interference. There could be a lot of cars. Is it interior the large machinery, or is it bottom of the ocean? Now that itself, brings its own challenges. How is it going to, transmit all of that content from the bottom of the ocean? What's the can the frequency able to travel through the water? And all those things needs to be considered. Okay. So surface of the ocean during tornado, biological, chemical contaminant field, nobody can get in. So how we going to detect and relay that information to the user? Battlefield behind the enemy line, home and large building, larger warehouse, animal, fast-moving vehicle, and drawing river moving with the current. Okay, so those things needs to be somewhat considered. Okay, so for the transmission media, what media are you planning to use? Is it going to be more of the radio, infrared, or optical media? Those are things that needs to be considered. Okay, and there is the power consumption. All of this requires power, like a sensing, requires power. How are you going to provide the power? Is it going to be more of the battery, or is that going to be more of the, wireless connection? There's communication and also the, power required for data processing. You have to consider all of that. Okay. So I want to end this short video here. Thanks for listening. Okay.